Good afternoon, dear students. I hope you are enjoying the lectures. It is, in fact, it is quite important that you enjoy the lectures. Don't take it as a burden, but you try to use this knowledge in your own work if you are going to the laboratory. So this is the third lecture, and for me, this is the last. So today, in the last lecture, I just introduced the subject of research methodology and also gave a list of the components of research methodology, which starts from the literature survey, making a hypothesis, and then carrying out the experiments, analyzing your results, interpreting the data, and finally you draw conclusions. Then you write the paper or the thesis, and then also present them orally in conferences or in the divisional seminars. So today I will discuss the research methods. Now this subject actually will be taught in more details in module C to you in your CIs. What are the different tools that you will employ in carrying out your research work would depend upon what is your discipline, what is the topic of your thesis. It could be theory, it could be experiment, it could be designing an instrument, it could be a simple survey and all that. So we will not go into the much details of the research methods. Maybe some of the examples will be covered. But today I will just give you glimpses of how in different types of research, which I listed last lecture, you can use the different research methods in a very general way. So the research methods will depend upon the type of research that you do, and I will take up all of them, about 6 to 7 types of different research, like hypothesis-driven research, making a measurement, or observational research, and so on. So, just to repeat, what is hypothesis-driven research? I discussed last time that hypothesis, it is a assumption that you make in the beginning of starting your research, and the hypothesis is like a statement which is falsifiable. Means you should be able to falsify it in your outcome of your experiment, or it may not be falsifiable also. You may conduct, suppose hypothesis may be true or false. So hypothesis-driven research is the most appropriate if you are trying to decide between a small number of exclusive cases. Suppose you have few options. It can be this way or that way. Then you make a assumption that it happens like this. For example, you are comparing two medicines, or you are studying the effect of these substances. If you suppose some substances like tobacco, smoking, alcohol. So what is the effect of them on the health of the human beings? Somebody say that it has got effect, somebody say it doesn't have the effect. So one can study in details by a survey or analysis of the health of people and so on. This particular type of research is not appropriate if you are trying to decide between a vast number of possible cases. For example, if you are doing a measurement of a quantity, a physical quantity like a density, then when you do the experiment with your densitometer, you may get several values, and there will be uncertainties in those values. So there's no point making a hypothesis in such cases. So whenever you have 1 or 2 or 3 alternatives, which the outcome could be 2, 3, or 1, 3, 4, then you can make a hypothesis. It should happen this way. So that is what you have to decide. Not every research has to be taken as a hypothesis-driven research. And in fact, the genesis of this hypothesis-driven research started from, what happens, when the people are developing vaccines, for some vaccination or prevention against some diseases. and then there could be side effects, or this may not work. So to protect the people who are developing those vaccines against the subtle biases, and these biases can distort the outcome of a research. And so when you are developing a medicine or so, which is a question of saving the lives, so it is very difficult to distort and difficult to avoid those biases. So, like for example, these COVID vaccines were developed in a very short span of time, and some of them may have side effects. So, but you must have seen, 2 years back, that when they are telling that what is the efficacy of this vaccine. So, how that efficacy has been arrived at by trying that vaccine on several people, and then trying to see what percentage of people are benefiting from this vaccine. So that is why, they may make a hypothesis that in their experiment, in their study, let us say 95% of people got benefited. The 5% may not have got benefited. So this is where the statistical aspects become very important. They don't say 100% it will cure, but largely in a large population it will cure. So that is to protect them against any bias. There could be some biases in the development of this vaccine or any medicine. So just to make it, that since you need to be saved, people need to be saved. They are developing some medicines, and to protect the researchers from any such cases, legal cases. So they say in this much percentage of people are affected by it. So that is how the hypothesis comes there. So how to conduct? What are the steps to taken to conduct a hypothesis-driven research? I also give you some of the examples. So you have, first thing is to state a hypothesis. Like if you do A, the outcome will be B. Like it can be cause and effect type of thing also. Design, and then you design an experiment procedure to test the hypothesis. And then you have to construct suppose you may need to make an apparatus, an instrument, or you may have to do some survey in the population, or you may have to do some plantation, some agricultural research, So different types of research design methods you will be using. That is what is meaning of the constructor and necessary apparatus. And then you perform the experiment to test the hypothesis. Whatever data you have got, you analyze them to determine how likely it is. You see, that is where the statistics comes into picture. How likely it is that the hypothesis can be disproved. So in how many cases, what is the percentage of cases? So how confident you are. So when you say how likely means how confident you are that the hypothesis can be nullified. So you have to plot your data and then make a statement about the truth or false of the hypothesis. And if it is, otherwise you may have to refine and correct the hypothesis and continue. If it does not meet your expectations, you can refine your hypothesis, you can correct it, and again start the next set of experiments. So that is what is the hypothesis-driven research. So how do you develop the hypothesis? It is not that suddenly one day you come into a laboratory and you can make an hypothesis. It requires a lot of preparations before you are able to make a hypothesis. So before starting the actual work, such as performing an experiment or a theoretical calculation or numerical analysis or making a model, we expect certain outcomes from the study. So you have to do a lot of preparation, literature survey, to come to a situation that you are able to predict. So that is where, for example, if you have learned the literature, what is being done, based on that knowledge, you make a hypothesis. So that is where you have to first do the groundwork, then make a hypothesis. Hypotheses are scientifically reasonable predictions. So basically, it's a prediction. If I do this, then it will happen. Like you can say if then. Means if this is the situation, it can happen. Or cause and effect. what is the effect of this attribute onto this phenomenon. So this type of sentences can make a hypothesis. So make hypothesis only after relevant literature survey. In your area, you need to do a thorough literature survey, and I think there will be somewhere down the line there will be lectures on how to do a literature survey, how to don't leave any stone unturned, they say. So that means it shouldn't happen that you have missed some particular work, and then you later on you will be repenting that you did not see that publication. So you learn the present status of the field of research by doing a good literature survey. And once you are sure that whatever you are making a hypothesis, it has not been tested before, then you can make it. After that, you formulate it based on the previous research and observations, and then you plan the testing of the hypothesis. So then that will give you the explanation of the different phenomena or events. So whether your hypothesis may be wrong or true or false, it can be validated or not, but it will be valid or not valid. But that you will come to know after the no, it will be valid hypothesis, but it may be true or false. So hypothesis has to be valid, but the outcome may be one way or the other. So that is what is the hypothesis-driven research. So the criteria of a good hypothesis are that it should have conceptual clarity and a theoretical orientation. See, when you make a hypothesis, that means you are trying to understand a phenomenon or a process, and then you predict that if I do this, it can happen. So you have a theoretical explanation in that, and your concepts are clear. You have read the literature. This is what happens in this particular field. It should be stated in a simple way so that it can be tested by the investigation. It should have at least two variables. So when you are testing your hypothesis, you have an independent variable, that is the cause, and a dependent variable, that is the effect. So you vary X and you measure the Y. So cause and effect type of studies one can do. For example, when you make a measurement of pH, you measure a pH, then there is a EMF is changing, and that you associate with the pH. And there is a relationship between the EMF and the pH. So the hypothesis gives us the opportunity to discover the existence of an unknown uncertainty. This unknown uncertainty is it is a phenomenon that can happen in any research. And it is important to understand that you cannot predict a outcome of a research. So when you say a hypothesis may have two outcomes, which can go this way or that way. But there could be a unknown uncertainty, means you have not envisaged, you have not factored that into your experiment. And so that is why in scientific research, you cannot be 100% sure that you will succeed in your experiments, because there could be some parameters which you have not factored. That is what is called the unknown uncertainty. So these are important, and you don't think that you have 5 years time, you are planning some experiment and you will get some publications in 5 years time. There could be some unknown uncertainty. Something may happen. Whatever you have thought of, it may not be really going that way. Some factors may change the whole outcome of your research. So how many hypotheses you can make? Poincare in his Science and Methods book suggests that a scientist must utilize few hypotheses. Don't make too many hypotheses. Otherwise, it is very difficult to find a wrong hypothesis in a theory, which makes use of many hypotheses. So science starts with general statement. You have one statement, and then you try to prove or disprove. Your outcome, mostly you will have one statement which can have this or that way options. Don't make too many hypotheses in the same research work. So let me give you some examples of a good hypothesis and a bad hypothesis. For example, A good hypothesis is like higher the altitude, higher the rainfall. So what you can do to test this hypothesis? You go to the different altitudes and you measure the extent of rainfall in different altitudes, and then may make a plot, altitude versus x-axis altitude, y-axis the rainfall, and you can see the correlation. It may be positive correlation, it may be negative correlation. So if it is positive correlation, your hypothesis is true. If it is negative correlation, the hypothesis is false. That is how you can plan the experiment. Smoking increases the chances of lung cancer. It is a hypothesis, a good hypothesis. You can, take the data of several people who smoke and see their health. Of course, this requires a long-term study. It is not 1 year, 2 years, maybe 10 years, 20 years. People have spent a lot of time on this kind of hypothesis. Ice cream melts faster than ice. You can do an experiment at home. So the time, you take ice cream, different ice cream, and see how they melt. Eating millets with low glycemic index controls blood sugar. So one can, do a good study by asking people to take low glycemic index millets and measuring their blood sugar over a period of time, maybe 6 months to 1 year, and come to a conclusion about the hypothesis. Now, the bad hypotheses are like this, For example, Pepsi is better than Coke. So it is not a proper hypothesis, no? How do you, what you would do to test this hypothesis? There is no cause, there is no effect. So it is a question of liking. Somebody may like Pepsi, somebody may like Coke. So it is not a hypothesis properly. Similarly, will fertilizer make a lawn grow more? It is not a hypothesis. It's a question. You can say that the fertilizer helps the lawn grow more. That is just a hypothesis. But you are asking a question. So this is also not a good hypothesis. It's a bad hypothesis. Some of the hypothesis, the statement and the comments you can see here, like eating 2 tablespoons of olive oil twice a day decreases the odds of contracting heart disease. You must have seen, a lot of advertisements about olive oil and its beneficial effects on the heart. So this is a hypothesis of a statement of a hypothesis, and it is a valid hypothesis because it can be checked by randomly assigning large number of people the diets that contain or do not contain 2 tablespoons of olive oil. So some people are fed 2 tablespoons in their diet, some people are not, and monitoring their health over a long period of time. So this is a good study. One can do this research using this hypothesis. Another one is the gravitational force between 2 masses is proportional to the products of the masses and decreases exponentially with the distance between them. So it is a valid hypothesis with regard to the product of M1, M2 by R square, but it is not exponential, but it is 1 upon R square. So also false, since gravitational force decreases at the square of the distance and not at the exponential. So that is how you can decide whether a hypothesis is good or bad or invalid. Okay, I'll give you one example. There's faulty experiment, example of a faulty experiment. And the hypothesis is that the bug can listen, the bed bug, So a scientist planned an experiment to prove that the bug can listen. The scientist asks the bed bug to move, and the bug moves. Then he plucks one leg of the bug, and then again asks move, and the bug moves. Take it in the lighter mood. The second leg of the bug is removed, and again he asks move, and the bug still moves. Continuing up to fifth leg, the fifth leg is removed. Again say move, and the bug moves. And the sixth leg of the bug is removed. He says move, but the bug does not move. So what conclusion did he draw? The scientist concluded that the bug cannot listen when all legs are removed. So this is a faulty experiment, you know. The bug is not able to move because he cannot move. He doesn't have any legs. But the scientist concluding that he's not able to listen. So this is how, you know, it has to be in sync with that. So what is your hypothesis and what is your experiment? They have to be proper. Okay, so I'll just give you one or two examples of the hypothesis. For example, now it comes to some of the relevant research. Some of you may be involved, people who are in the field of agriculture, nuclear agriculture. So you don't worry too much if you don't understand what is it about. So the hypothesis is saying the ionizing radiations enhance mutations in crop. It may enhance, it may not enhance. So experiment is done. What experiment is done? You take the wheat grains, irradiate with the gamma radiations up to a particular dose. The gamma radiation may cause some genetic changes in the DNA, and then the change, you know, the seeds, irradiated seeds, you show in the fields, and you see the plant. You observe the plant. So some of them, you know, like in terms of the height, you can say that this plant is, you know, negative mutation means it reduce the height is reduced. And if your purpose is to increase the height, here there is no effect on the height or the quality of the seed, whereas here the height is good, the seed quality is good. So basically, you are trying to improve the crop by means of radiation, and this is based on the two principles: genetic variation. So genetically, because of the genetic changes by radiation, the plants, some of the seeds may undergo mutation. The mutations have been accelerated by radiation. And then you select the ones which have improved their traits. What are the traits? Early maturity, higher yield, resistance to diseases, even the plant height. You may like to have a dwarf type of variety of the plant. So all this, and you can select, then multiply 5-6 times before the genetic changes get stabilized. So this is the kind of experiment, and I'll show you one of the examples of this. This is an example of a dwarf variety of Dubraj somewhere in Madhya Pradesh. So it got matured early. The height of the plant is less, shorter than the original plant, and the yield was higher. So early maturity, lower height, and higher yield. These are traits which are better than the traditional crop. So this is what, so that you can say that ionizing radiations do enhance the mutations in the crop. This is the example of that. That is what is the meaning of hypothesis-driven research. You have in your mind that you want to improve the variety, the crop, and you plan the experiment. No, this experiment, whole thing will take 3-4 years. It is not a matter of one day. You do it over a period of time. Similarly, I just give you an example in nuclear physics. You can say nuclear chemistry also. So you have a process called incomplete fusion. A projectile and a target can fuse together by complete fusion, or they can undergo incomplete fusion. I have taken a projectile, carbon-12 and carbon-13. The structures are different, and that is why the projectile structure becomes a parameter. And the target is same. So the complete fusion means the two projectile target will fuse together to form a compound nucleus. It will evaporate in alpha particle and 4 neutrons to give you 185 iridium. Whereas the incomplete fusion means the carbon-12 does not fuse completely. 1 alpha comes out of carbon-12 and the remaining beryllium fuses, and it can again emit 4 neutrons to give you. So the same product is formed by two different reactions. One is complete fusion and one is incomplete fusion. The hypothesis is that this incomplete fusion probability depends upon projectile structure. So what you do, you carry out this experiment at different beam energy of carbon-12 and carbon-13 and find out the fraction of incomplete fusion over the total. Incomplete fusion upon the complete plus incomplete fusion. And you can see here, the carbon-12 is having higher cross-section than the carbon-13. And so you can confirm, you can make a statement that yes, the hypothesis is true. That means incomplete fusion probability indeed depends upon the projectile structure. The projectile is an alpha cluster. It has got higher probability of incomplete fusion. So this is the kind of, you have a conceptual clarity in your mind, what you are studying, and you do the experiment properly, and you can conclude based on the experimental output that you have proven the hypothesis. That is what is an example of a good hypothesis. So this was about the research methods. You can have different research methods depending upon your type of research. You can employ different research methods to test the hypothesis in your work. The second type of research is a measurement of a value. So you have basically an experimental research because you are having some instrument by which you are measuring the quantity, experimental quantity. So you identify a well-defined quantity, what you want to measure. It can be temperature, pressure, anything, density, whatever, charge of anything. Design a procedure to measure it, perform the experiment, analyze and report on the accuracy of the. So these are the steps that you will be following to measure the value of a physical quantity. Some of the examples of that measurement of a quantity, like density of crystalline silicon at room temperature. So this is the objective of your research. You are measuring one value. So you cannot make the hypothesis in such a case because density could be anything. So you do this second type of research where you do an experiment to measure the value. So it can be obtained by separately measuring mass and volume of crystalline samples and taking the ratio. So when you measure the mass of a sample, you measure its volume, you will find that there will be associated uncertainty in the measurement of mass and measurement of volume. And when you take the ratio, you get the density, the errors will add up. So this, when you finally put density like the rho, let us say 1.5, it will have always plus minus something. So whenever you are quoting a value, experimental value, always quote the uncertainty on that value. Similarly, the charge of an electron. In fact, it is very interesting story about the Millikan's experiment, Robert Millikan's experiment, who for the first time measured the charge of an electron. It is interesting. You must see this work, So when he first time measured, he did not take the effect, the effect of temperature on the buoyancy of it is falling down, the oil drop that was falling down, And so, but at that time, that was the most accurate value. And after a lot of times, few years, few decades, in fact, it was corrected by taking care of the temperature dependence of the speed of the falling drop, the buoyancy of the air. Because air density will change with temperature. Similarly, the distance from the Earth of the nearest star other than the Sun, like Proxima Centauri, which is 4.22 light years from Earth. So you see, the 4.22, somebody must have measured it. NASA, in fact, did it in 2008. And I don't have the plus minus, but definitely there may be plus minus. But I believe that these are very accurately measured, rather very precisely measured. So accuracy and precision are the two, again, two aspects of a measurement that will be taught in the next part. Number of base pairs and distinct genes in human genome. These are the kind of, you are doing the measurements. And the genome 2008 was a project in which it was found that the number of base pairs around 3 billion and number of these distinct genes is around 330,000 in the human being. So this is the kind of research, the molecular biology people or genetic engineers people, genetic engineering, they have done. So the value, any measurement, when you do a measurement, make sure what are the different attribute, what are the different parameters which may lead to factors which may lead to uncertainty in your number, and you must factor those uncertainties. And one of that is, once you try to repeat the experiment multiple times to decrease the plus minus the standard deviation. At the same time, if you have some standards, so that is to determine the accuracy of your measurement. The third type of research is measure a function or a relationship. Again, this is the experimental research. So you are measuring the cause and effect type of thing or a functional relationship between two quantities. So observe a phenomenon and develop testable questions. Identify control variables and response functions. So you do some like, for example, the effect of fertilizers on the growth of the plants. The quantity of fertilizer is one parameter. The time when you apply the fertilizer, another parameter, and the plant growth or the nutrient content of the plant, these are the response functions. Design an experimental procedure to vary the control variables, measure the response variable, and keep other factors constant. So this is the study. Then perform the experiment. Analyze the relationship between control variable and response variable. Characterize the relationship mathematically. See, many of you, your work may fall into this category. For example, just give you some examples from the Marder's book. Find how the speed of sound in air at fixed pressure depends upon air temperature. So the speed of sound can vary with temperature. So keep the pressure constant. So what is the control variable? Temperature. The response variable, speed of sound. So this is a common experiment in physics and chemistry, what you can do in your laboratory. In fact, I am giving you some of the examples. There could be some assignment to you later on to perform an experiment and report the results. So one can take up this kind of studies which you can do at home or even in your laboratory in a short span of time. Place a fluid between two cylinders. So you have two concentric cylinders, inner cylinder and outer cylinder. Rotate the outer cylinder and find the state of fluid as a function of rotating speed. So the fluid between the two cylinders, might undergo changes, like, is from the uniform motion to rolls to turbulence. So these are the kind of studies one can do. So you have a control variable, that is the rotational speed of outer cylinder, and the response variable is state of the fluid. The fluid could be, initially it could be smooth, uniform motion. It can form rolls with higher speed, and later on there could be turbulence in the fluid. So you can study the effect of the rotational speed on the fluid. Similarly, measure the stiffness of rubber as a function of cross-linking agents. See, rubber is toughened by using sulfur. So it's called vulcanization of rubber. Or you can even use radiation dose to strengthen the rubber. Otherwise, rubber is very soft material. So the control variable is the cross-linking agent. It could be sulfur content or it is radiation dose. And the response variable is the stiffness. So it is like an industrial research. In the industry, people do this kind of research to optimize the dose or the quantity of sulfur to obtain the rubber of a particular stiffness. The fourth type of research methods includes construction of a model, like political science and applied mathematics. So, like, you can choose a relationship discovered through experimental investigation. So when you are doing some, in fact, one can even do a good It is a survey, and using that itself, you can make a model to construct the mental pictures to explain the relationship and develop hypothesis about origins of certain phenomena. So in your own area, if you have if you collect the literature, and then you can study that and try to arrive at some correlations. Then you can make a model. Identify basic mathematical equation from which the relation might result. So I think the mathematics students and the theoretical physicists might be already doing this kind of research. Using analytical or numerical techniques, determine whether the empirical experimental relationships result from basic mathematical equations. So you can try to fit them into analytical functions, or even the numerically, you can try to arrive at some functions. If incorrect, find a new mathematical starting point. And if correct, predict the new relationships to be found in future experiments. So you can give a new theory that this behaves this way, not the one published in the literature. So I'm sure that many of the theoretical physicists and applied mathematicians are using this kind of research tools. For example, again giving you this, a fluid is placed between two concentric cylinders with the outer one rotating. They calculate the rotational speed at which steady fluid motion becomes unstable, and finally formation of rolls take place. Similar to the one explained earlier. That was just to enumerate the data, whereas here you are trying to make a model. And this actually this is based on the Navier-Stokes equations. The computation was first carried out by Taylor in 1923 using Navier-Stokes equations, and constituted the first non-trivial comparison of theory and experiment for fluid motion. So computational fluid dynamics, people who are in mechanical engineering or chemical engineering might be aware of this kind of relationships. Find the arrangement of atoms in DNA, a model of a DNA. Watson and Crick in 1953 determined the structure of DNA as a double helix with a schematic diagram. These are the models, theoretical what people are doing. Then predict the weather in your city 2 days from now. So you have to have a model. So how do you predict the weather? So this requires a vast collection of data from weather monitoring stations around the globe, and then you computations using equations for the motion of air, including temperature, pressure, and humidity. So you must have noticed that in particularly in western part, they are able to predict the conditions, the weather conditions very accurately. If it rains at this particular, if they predict it will rain at this time, it will rain. It will snowfall, it will snow. So even in the precipitation, the rain, the snow, or even there is something called flurries, like the flowers, the petals of a flower, this kind of snowfall also takes place. And in our monsoon, the prediction of monsoon is quite difficult because the parameters are quite many probably, and so you will find many times, the predictions in the monsoon are not that accurate as in the non-monsoon areas. But this is all requires modeling of the data. Next comes the observational and exploratory research. A lot of people are working on this particular area. So for this may require doing even planning an experiment. You can develop an instrument for that particular experiment. To create an instrument or method for making observations that have not been made before. Always think of something new which will produce some data which are quite different from what people have been doing earlier, or more accurate or more precise measurements. Carry out observations regarding as much detail as possible searching for unexpected objects or relationships, and present the results and stimulate further research in your area. So, a lot of people are working on this kind of observational and exploratory research. Just to give you an example, it is all a little bit of historical development also. Find how the position of Mars in the sky varies over times of minutes, hours, days, and years. So it is an excellent study, So you have to develop a telescope. So in fact, this Tycho Brahe, he was a pioneer in developing astronomical instruments to measure the position of planets and stars in the sky. And in the late 1500s, and later Kepler, in fact, interpreted some of his observations, which played a critical role in the development of modern astronomy. So, see, whatever today you see, whatever you are doing, if you are working on astronomy or astrophysics or any area, agriculture, genetic, molecular biology, you will find that for last many centuries, several people have toiled hard to develop, to produce that knowledge which is present to you in books. Another very interesting, those who are in the evolutionary science travel to Corbett National Park, make careful observations about wildlife. What Charles Darwin did in 19th century. Charles Darwin observed the wildlife of the particular islands, Galapagos Island, during 1831 to 1836. He spent 6 years in that island, and he found that these birds called finches, they have beaks which are adapted to different food supplies, different regions. So the finches of different regions had their beaks which are adapted to the food supply. So depending upon the type of fruits they feed on, they had developed those beaks of that particular type. So this is how he gave the theory of evolution. So this has happened, Darwin gave this theory because of this research only. It is not just suddenly, you have the eureka moment. It's not a eureka moment. He did a lot of experiments and then found out that the relationship, why these different finches have different beak shape. He drew the conclusion based on his observations. Similarly, use MRI to map regions of activity in brain of a patient undergoing an epileptic seizure. So, epilepsy is a dreaded disease, and MRI can in fact tell. So, functional MRI was developed. It produces images rapidly enough that it can be even provide information on the state of the brain during specific activity. So, this is also, magnetic resonance imaging has now given us a tool to probe the brain activity when a person is like, people are studying that when you dream in the sleep, what happens in your mind. So by MRI, people are studying the dream process, dreaming also. Another very interesting example, and you also, again, I caution you to take it little lightly. Observational research, there are a lot of this kind of research you will see in papers appearing now and then. Fit and tipsy means the interrelationship between cardiorespiratory fitness and alcohol consumption. In fact, this paper, what happened actually about last year, while I was taking these lectures, I read in the newspaper, the Times of India, and this topic, that is, people who consume alcohol, they are more fit. They have, with regard to cardiorespiratory fitness, their health, their heart condition is better than those who don't consume alcohol. And later on, I found that this had been published in a journal last year itself. After this was published, this Times of India brought this article. So, Medicine and Sports Exercise 2022, what they did is, there is a hospital, Cooper Clinic in Dallas, Texas. They surveyed 38,653 apparently healthy patients who have been visiting this clinic for preventive medical examination during 1988 to 2019. See, you can see about 30 years, 31 years, these doctors studied these patients and concluded that higher fitness levels are significantly related to greater alcohol consumption among a large cohort of adult patients. Now, you see, you can see the wordings of this. It is not that higher consumption of alcohol will keep you high fitness. Significantly related to greater alcohol consumption. That means that the confidence level, when you plot the data of 38,653, you do a frequency distribution, or since it is a very large number, they will fall upon a Gaussian, and you try to find out the confidence level of the people who have consumed alcohol and their fitness. So try to drive this correlation. They found that in a significant number of people who had higher fitness levels, they have been taking greater alcohol. And they caution also, it is not necessary that people should take alcohol to be fit, but it is a finding. Again, as I was told, no hypothesis, it could be, one can make a hypothesis that greater consumption of alcohol leads to higher fitness. Very careful, one has to be very careful. So it is a observational research. They did not assume anything, but they just observed so many patients and come to this conclusion. Then you have improve a product or process in the industrial and applied research. A lot of people, in industry are, trying to develop to improve their products to meet the market requirement. To identify the market need, this is something called trend forecasting. 5 years down the line, what will be the requirement of the people? People are doing a lot of research. So if you have something in your mind, do a market survey, what people want in this product. Design a product with the potential to meet the need. Build a prototype product. Then determine whether product functions as per your desire, as you desired. Then optimize the product with respect to the cost, speed, environmental consequences, and other factors that affect the profit. And then bring the product to market and continue. You must be seeing, many new products are coming into the market, and a lot of research must have gone. They compare, So anything you see in the advertisement these days, a lot of research has gone as an input, and then they compare, this is better than the things and so on. So this is what is another area, industrial research. A lot of things are done. For example, create a device from semiconductor materials capable of amplifying electrical currents. This is about 1940s, and that is how the transistor was developed. So this transistor was developed from intense 3 years research at Bell Laboratories in USA in late 1940s. So this was led by William Shockley and John Bardeen. And then after that, there was a revolution in the electronics industry. How from the valves to the transistors, big change in the industry. These are path-breaking developments. Create new small molecule inhibitors of protein kinase B as anti-cancer agents in biology, cancer research. So in 2005, there was a business agreement between AstraZeneca and the smaller firm Asterix for specific goal-oriented nature of drug design. So the cancer research got a big boost after this particular research agreement. Similarly, write programs that regulate, control scientific instrument through computers rather than physical knobs and switches. Earlier we had instruments we used to operate the knobs. Those of you who are working accelerators in VCC, I remember we had there is a trip, several control valves will be moved, but now you have the computer controlled machine. So whole thing has changed, and that happened because of the development of LabVIEW. You people are all probably aware of LabVIEW. LabVIEW was first released in 1986 by National Instruments after 3 years of intense engineering and development. So it's basically based on the computer programming language, which helps the control of scientific instrument from a circuit diagram drawn on a screen. So there have been this kind of path-breaking development from the industrial research. Why I am giving these examples, that will motivate you to think of some innovations in your own area. So don't have to do only mundane research, whatever is happening. It is tough. It is no doubt tough, because you whatever you think, you will find somebody has done it. But as I told, now, if you really think very deeply, you may get one day to get 100 ideas, maybe one of them will succeed, will be a novel one. You will get publications anyway and you get PhD degree. But if you can bring in some innovation in your work, you will be known more for that than just simply being one of the PhD students. So lastly, you have this allied areas of service research. This is like a library research. There are people who are working on library, how the archives are maintained. And it is rightly said that it is futile to move very far through a project without attempting to determine whether the answer is already known. So it is for you. What I am telling you, that a literature survey is one, but at the same time, in library also there is a research how to archive the information in lab. Now you must have seen, our time we used to go to physically to different abstracts. There used to be a book of abstracts, and then from note down from that, then you go to actual papers. But now you have everything on the click of a button in the computer, and you get all the data. Pure mathematics, again, it is a wonderful research, and I quote from one of the books. An engineer thinks that his equations are his or her, I should say, are an approximation to reality. A physicist thinks reality is an approximation to his equation, but a mathematician does not care because he enjoys doing it. Much of the pure and abstract mathematics was developed because of the desire to solve scientific problems. Computers and computer science. Computer science is no more about computers than astronomy is about telescopes. And computers have changed the way science is practiced in many, many ways. Now computers have come in our daily life in such a way you cannot think without computers. So that's all I had to say today. I just gave you glimpses of different types of research methods that one can employ for different types of research. And I'm sure that you have already embarked upon some research, and you can try to correlate your work with one of these kind of different types of research. So now if you have some questions, you can ask me. You can write in your chat box, and I hope you have written your registration ID in this, so that you are not marked as absent. Okay. There is a chat. Thank you, sir, for your lecture. It will be very helpful for us if you kindly share these slides. Yes, these slides will be available in Anuvidya. I will ask our colleague who is maintaining this system. So I think they are available in this laptop which I am using. They will upload onto the Anuvidya portal. Suppose we will make sure that it reaches you. Suppose it is not put onto Anuvidya, we will have a email ID of all the students. It can be sent by email also. Any other questions? Yeah. Till now, I cannot register myself for this class. Somnath Dalal. So I hope you have written to Monday. Can you write whether you have written to help desk about your registration? Please write yes or no. Have you written an email to helpdesk@hbni.ac.in about your problem? Yes, sir. So he has written. It is there. You can confirm. Monday you will get. You register. Already requested. Okay, good. You will be registered. Keep attending by YouTube. But how he is attending by YouTube? Because we are provided. Okay. So don't worry. It will be done. Any other questions? Sir, can we attend by YouTube live? It is live only. Yes. You have been attending live only. It has not yet been put in on YouTube. It will be put afterwards. So right now you are live. The fact that you are able to write to me means you are live. Any other question? 177 views. Yes. Yes, they are right now 177. Can we attend by? Okay, so that one was the chat. Answered. Huh? Already answered. No, that chat came. Now it is not seen. No, so that comes separately. No, the question, no, it's not seen now. Can we attend live? Where is that? Oh, so you have two, YouTube and WebEx. Okay. Okay. So we have to toggle between YouTube and WebEx to see the questions by different. Okay. Any other questions? If any student has, you can write. You can write, type in the chat box, and we will answer. There is a delay between when I'm speaking and when it appears. Yeah, sir, in slides, I read higher fitness levels are significantly related to greater alcohol consumption. But few days ago, I had read also in TOI that who warned no amount of alcohol is safe to drink. Yes, you are right. So this is what I was telling. That is a study. So when you do a study, you present your observations. In between 1988 and 2019, they have surveyed 38,000 people who have, depending, and then they try to classify them based on their alcohol consumption and their level of fitness, and they draw a correlation. So it is not that it does not. It means they don't suggest that alcohol consumption is good for health. What they concluded that the people having higher level of, or what we can say, that higher level of alcohol consumption is correlated with a higher level of cardiorespiratory fitness for that sample. So it does not suggest that people should take more alcohol and that is only for cardiorespiratory. Some people may have other problem, like for example, alcohol, we know it is not good for liver. So if somebody takes more alcohol, there is a chance that liver may get affected. So who has rightly warned people? In fact, after that, there was a lot of information about this alcohol consumption and the health. So that was about the cardiorespiratory fitness. High level of fitness means when they are asked to undergo the cardio test, they succeeded in that, like stress test, So you are right. You are very much right that who has warned people, no amount of alcohol is safe to drink. But there have been a theory earlier that 60 ml of alcohol, they will say there was a study earlier, it is good, but now, so it can change over a period of time, it can change. So we don't have to make a theory. Can we get to see a record of our attendance? Right? Oh, your attendance is being recorded, and you have to attend at least 75% of the lectures. More the better. So in fact, I can tell you, last year 302 students attended, and most of them, rather all of them, attended more than 75% lectures. So don't think of bunking the classes. Okay. So do this lecture. Let me start from beginning. From inside BARC, WebEx access is not there. Very true. Hence, I asked if YouTube is valid option for us. Yes, it is good that you asked this question. I know in BARC, WebEx is not. You will get WebEx access only in probably group offices or conference rooms. So you can always attend through YouTube. Then another question: if this course available on NPTEL, if it is there, it will be good, great help for self-paced learning. So right now it is not available on NPTEL, but it's a good suggestion. We can think of making it for NPTEL in due course of time. Next question is: do this lecture series contain information and tools for thesis writing? You are very correct. We will be having a lecture on writing papers and thesis also. So Professor Nayak will be taking lectures on how to write a paper, how to write a thesis, how to communicate orally also. They are a part of communication. So you should be able to communicate your work effectively in writing as well as orally. Good. Any other question? Let me see. Can we get the slides? Slides you will be getting. Huh?
It will be on Anuvidya portal.
It will be, the slides will be available in Anuvidya portal. So already it is there, Rishabh, no? You can upload these 3 slides
Yes,
onto Anuvidya.
Yes,
okay. Yes. They will be uploaded onto Anuvidya. And yeah, the next lecture from Monday onwards, Professor Nayak will be taking. And there probably you will have a much better system where he will be able to draw the things right on the board. So you'll be able to see any derivations or any examples, you know. Yeah. Right. Today, this time, last 3 lectures, I was just showing the slides because I don't have the facility to do writing on the board. But next lecture onwards, you will have you can see the derivations and other things. Can we get to see a record of our attendance? How you can see your attendance? That part you will not know how many lectures, but you are anyway attending, so you will know how many you have attended, and you do not worry about others. So you have 30 lectures. You know which lectures you have attended. Can you go to YouTube once just to see? Any other questions? There are no questions. Okay, I think we will stop here, and you can write to me anyway if you have any queries later on. Okay, so all the best, and you will come back on Monday afternoon. Thank you. Bye-bye. Yeah. And his record, he knows.